Hello everyone, I hope you're doing fabulous today. So in the previous two videos, we talked about significant figures, numbers in a measurement that speak to the precision of a measurement. We talked about how to determine if a number in a measurement is significant, and we used rules to make that determination. Now we're going to use those rules not just by looking at individual measurements, but use those rules of significant figures in regards to calculations. Because even though we're not going to be together in lab doing calculations together, you are going to be doing a lot of calculations with numbers, with data that we give you not only in lecture, but in lab. And when you do those calculations, you need to keep in mind the rules for significant figures. And so that's what this video and the video after is going to address and do practice problems on. So, significant figures in calculations. So, when you do addition or subtraction with particular measurements, the rule for your final answer in significant figures is that your answer, your result, has to have the same number of decimal places as the number or the measurement with the fewest decimal places. Okay? So it's all about fewest and it's all about the decimal with addition and subtraction. So in this example, I have three numbers here, and I'm going to add them. So just to practice our significant figure rules, this first number 5.74, it has a total of three significant figures. All those numbers are non-zero. But for addition and subtraction, I only care about number of sig figs after the decimal. So 5.74, it only has two significant figures after the decimal. 0.823, it has a total of three significant figures, and all three of those sig figs are after the decimal. Then for 2.651, I have a total of four sig figs, three of which are after the decimal. So when I add those numbers, if you were to add these three numbers in your calculator, what comes out is 9.214. But when reporting that final answer, we need to remember that our answer, our result, has to have the same number of decimal places as the quantity with the fewest decimal places. Both 0.823 and 2.651 have three sig figs after the decimal, but 5.74 has two. And since 2 is less than 3, that means my final answer can only have two significant figures after the decimal. So my final calculated answer in this example would be not 9.214, but just 9.21. Two sig figs after the decimal. Now note that for addition and subtraction, I didn't care how many sig figs are before the decimal place for my final answer. Okay? I could have had 20 or 30 before if that's what I was given. When you add or subtract two or more numbers, your answer, your result, has to have the same number of decimal places as the quantity with the fewest decimal places. So that's for addition and subtraction. I think multiplication and division is a heck of a lot easier, which is good because generally in chemistry you're going to be doing more multiplying and dividing than adding or subtracting. And the rule for multiplication and division is easier because for that rule, you don't care about number of sig figs before or after the decimal place. You just care about total number of sig figs. Because for multiplication and division, your answer, your result, has the same number of sig figs as the number with the overall fewest sig figs. So let's say I was multiplying these three numbers. 5.02, which has a total of 3 sig figs. 89.665, which has a total of 5 sig figs. 0.10, which has a total of 2 sig figs. Remember, this first 0 is not significant because it's to the left of the decimal. putting all three of those numbers in your calculator, this is what spits out. But to report your final answer with correct sig figs, remember you have to have the overall fewest sig figs. This has 3, 5, 2. 2 is less than 5 and 3, so my final answer can only have 2 sig figs, which in this case is going to be 45. So your final answer for this problem would be 45. Not 45.0, because you only want 2 sig figs, just 45. So that's the rule for multiplication and division. You want your final answer to have the same number of sig figs as your overall fewest in the equation. Now let's talk a little bit about rounding. So when rounding, you have to remember two more things. So with significant figures and rounding, you round down if the last or leftmost digit is 4 or less. So for example, let's say I have these two numbers, 3.54 and 9.4810. If I was to add those up, this is the number that would spit out of your calculator. But remember, okay, that's the first part. Then you have to remember for sig figs, the rule for sig figs. Oh, I'm adding, so I care about number of sig figs after the decimal. This has 2 sig figs after the decimal. This has 4. So my final answer can only have 2 sig figs after the decimal. To determine if you round up or down, you look at the digit that's next to the last digit that is significant. So I know I need to have 2 digits after that decimal, so I look next door. It's a 1. It is 4 or less, so then I'm going to round down. So I would drop those 2 and we just have 13.02 as my answer. If that digit was 5 or greater, then you would round up, which is what happens in this example down here. I've got 3.21 minus 2.554. I know I can only have 2 digits after the decimal because of the rule for subtraction. So I look at the digit next door, the digit next to the last significant figure. It is greater than 5. It is 6, so I'm going to round that next digit up so that 5 becomes a 6. So my final answer would be 0.66. So the rules for rounding: you look at the digit that is next to the last significant figure. If it's 4 or less, then you round down or you drop it. You round up if it's 5 or more. In the next slide, we'll talk about how to use rounding rules and sig figs in more complicated calculations.